Deals with locus, and it's the set of points. The term locus actually means location, and so what we're going to be trying to figure out is the location that meets a certain condition or a certain requirement. An example would be if I wanted all the points that were 4 inches away from my marker that are in space, in 3D. And what that would be this sphere going around it. But I could also think about what are all the points that are 4 inches away from this point A on this plane. Well, all of that would be, all the points that are 4 inches from that point A would end up being a circle. But I could also look at, if I had this point A on a line, and I said, where are all the points that are 4 inches away from A on this line, then it would be this point right here and that point right there. It'd be 4 inches away from that point on that line. So we kind of have to think about what kind of things meet the criteria, what kind of things meet the requirements for that particular locus. If I would do the example of in a plane on this flat surface, if I had this circle C, and I wanted to have all the points that are 3 centimeters away from C. What that would be all of these points going around here. It would be a circle that had a radius 3 centimeters bigger than the original one. How about if I had 2 conditions that I wanted to meet? Let's say that I have point P right here, and it is 10 inches away from point Q. So there's 10 inches away between those two. And what if I said, in this plane, what are all the points that are 6 inches away from P, and they are 8 inches away from Q? Well, when I give 2 different requirements, what you need to do is graph them out separately. So if I'm going to graph out 6 inches away from P, if this is 10, 6 inches is just going to be a little bit away from that center point, right? 8 inches from Q would be, oh, I'm almost up to P here, and I would have this circle that goes 8 inches away from Q. Well, where am I both 6 inches away from this and 8 inches away from that? There are 2 spots that meet both of those requirements at the same time. The first one would be this point right up here, and the second one would be that point right there. So when you have 2 conditions that you have to meet, if there's an and in between there, graph out the conditions of the first one, graph out the conditions of the second, and your answer would be where those 2 overlap. Okay, now we can do a different example using almost a flat surface. If I have plane M, okay, we know how to draw out plane M. If I want all the points that are 4 centimeters away from this flat surface, so this flat surface is like a piece of paper floating. Where are all the points 4 inches away from that? Well, they could be 4 inches above that. Okay, so there's another piece of paper floating above, but it could also be floating 4 inches below this thing. So around this piece of paper, there's a whole set of points that are 4 inches above it. There's also a whole set of points that are 4 inches above it. And since these are planes, these go on forever, all the way around where it is. Another example would be as if I would have a line segment. If I have this line segment PQ, and I want all the points in this plane that are 4 inches away from this line segment. Well, I could have these points up here that are 4 inches away. I could have these points below, that's 4 inches away. But what would happen here on the ends? On the ends, it would just make this half circle. It would make this semicircle. And what would be the radius of that? That radius here would be these 4 inches. And up here, this distance would be 4 inches. I'm completely away from this thing, 4 inches. Almost looks like I don't call it a big pill, a big horse pill or something that's going around. It's this big pill going all the way around. Now, what would change if I said I wanted to be 4 inches away from line PQ? Now what would it be if I was trying to do this point? Well, now if I wanted this 4 inches away, I would have this line above that was 4 inches away, and I would have this line below that was 4 inches away. And it would be two continual lines that were on either side of this 4-inch, this line PQ. Now if I wanted to do this in space, what are all the points that are 4 inches away from PQ in space, in 3D? Where would this be? Well, what it would end up being, end up being this curve or this cylinder, this never-ending cylinder that goes on forever in both directions. It would be this ending tube going around this PQ in space all the way going across. Okay, so sometimes we have to think about it in a plane, sometimes we have to think about it in space, and we have to just kind of figure out which one it is. If I have this point, if I have 2 points here, and if I said I want, in this plane, I want all the points that are equidistant away from those two. Well, equidistant means the same distance away, so this would be an obvious point that would be the same distance away from P as Q, but is that the only one? No, there'd be another one here that would be the same distance away from P and Q. There'd be another one down here, and if I would just keep on adding these lines, adding these points, you know, this point right here, 10 inches away, 10 inches away, they're all equidistant. Well, how does this line compare to PQ? If I would kind of draw in my line segment PQ, what do you notice? What about this distance to this distance? That would be the same. And what do you notice about the angle of how this one meets that one? It is perpendicular. So this answer is this perpendicular bisector line between those 2 points. Anything on this blue line is the same distance away from P as it is for Q. Well, if we can do that, we can also graph this out on a graph. If I would tell you I have the 2 points of P is the point 1, 3, and Q is the point 5, 1. If I graph out those 2 points, 1 over, 3 up, 3, 4, 5, and 1 here. So there's P and Q. If I want to know what is the equation of the line that is equidistant from both of those, well, what we're going to be doing is we're going to be trying to find the equation of the line that goes right through there, which is the perpendicular bisector. Well, how do we write the equation of the line? It's been a while since we've done that. And if you remember, there was this equation, y minus y1 equals m times x minus x1. We did this thing back in chapter 3, so it's been a while. So what do we need? Well, we need, this is a point that is on the line. And what does m stand for again? M stands for the slope of that line. Well, what is my slope? Well, the slope of my dotted line here is going to be the perpendicular slope to this one. Well, how do I find slope again? I have to do slope by subtracting these y's. So I'm going to go 3 minus 1, and then I have to go the same order to going this way. It's 1 minus 5. 3 minus 1 is 2, 1 minus 5 is negative 4. So the slope between P and Q is negative 1/2. So what's going to be the slope of my line? Remember, with perpendicular lines, they are the opposite reciprocals. So the slope of my line that I want, instead of being a negative 1/2, what do I want it to be? I want it to be a positive 2 over 1. That's my slope. Now this other thing is a point that's on the line. Well, how do I find a point that's on that line? Well, there's one easy one that's easy to find. It's this one that's right in the dead center. That's the midpoint of those two that were given. So what's the midpoint of this x? 1 and 5, what's the midpoint of 1 and 5? Well, I add them up. 1 plus 5 is 6. 6 divided by 2 is 3. That's my new x term. So this point right here has a coordinate of 3. What's my y term? I went from a positive 3 to a positive 1. What's the midpoint for that? That would be the point 3, 2. Now I can go ahead and put those into my thing. Which is the number that I would put here in this box? Well, it's the y term of my point. Well, the point that I have here, I would put a 2 in here for that point. And here in this box, I would put an x, which is my 3. Now, does this answer make sense? Well, let's simplify this a little bit. This is y minus 2. This is, I'm going to do distributive property here. What's 2 times x? That would be 2x. And what's 2 times a negative 3? That would be negative 6. If I now add 2 to both sides here, I get the equation y equals 2x minus 4. Does that make sense for this equation right here? Well, this is slope-intercept form, right? What does this negative 4 tell me? Negative 4 is where this line is going to cross the x-axis. Does it look like this line will approximately cross this line at negative 4? Yeah, that makes sense. And this one here, this 2, represents my slope. Well, does it make sense that this would have a slope of 2? Would I go up 2 over 1 on every point of this line? Yeah. So this is the equation of the line that is equidistant from those 2 points. And you have to do one of those on your assignment. When you're trying to graph them, just graph them the best you can, trying to represent what's going to happen. There's some different examples there. I know one of the problems says if I have this angle, and you're going to have to do a lot of drawing for this lesson. If I have this angle and I want all the points that are the same distance away from both of these sides, well, where would that be? This point right here is the same distance from here as it is from here. This point right here is the same distance from here as the same distance from here. And what would happen if I just kept drawing in all those lines? It would be this, this angle bisector would be where that line is. If I said now, okay, I want that same thing, I want 2 conditions. Equidistance from both sides of this, and let's say 6 inches from this point P. Well, it has to be both of these things. It has to be on this line, and it has to be 6 inches from P. Well, where would be 6 inches from P? 6 inches from P would be this circle with a radius of 6. And if I have 2 conditions, I graph out both of them, and where does this dotted line match up with this circle? My answer would be right there at that spot. That's the point that is on the angle bisector and is 6 inches away. So you're going to be doing quite a bit of graphing for these. Draw out what they want you to find. Draw, if it's going to be from a line, it's going to be from a segment, draw out that segment, and then with a different color or pen or marker or something, draw out what you think your locus will be. On the test or the quiz, I'll actually give you a colored pencil so that you can draw in your answer. But here is the assignment for tomorrow. 11-6A, it's page 623 to 625. It is numbers 1 through 21. The odds, numbers 31 through 39, the odds, and number 43 to 46. That is the assignment for tomorrow.